you want to start or do you want me to?
You can start.
Okay. That didn't work. Screen. This. Can you see that?
Bear with me, I just changed screens. Yes, I see a low-level controller on the left-hand side.
Okay, so what I did was this last week, I kept thinking I need to figure out some way to document whatever I'm doing and kind of use it as a design tool. So I went through and said, well, this is basically what my low-level controller is. So I've got a block that's actually a microcontroller. And you can see on the right, I've got 3 encoders hooked up to it. I've got the big motor driver, that 30 amp power driver. And I've got the giant RC servo on the front for the steering. I've got that little PWM board like Bob has, and I'm using to run my flashing lights on my vehicle. So basically, I just send out, say, channel 3, set it to this value of PWM, and it does that. And then down at the bottom, I just show my remote control receiver, and it's got a CAN interface to my low-level controller. So it's just saying this is what my low-level stuff is doing, just a very basic conceptual drawing. And at the very top, it just shows that it's a USB connection that goes back to my ROS computer. And the reason why I put this is because the next screen, it will say, this is the low-level controller. So here it just shows in this block, it shows my low-level controller. And then on my, so here, this box that says ROS, that's what's running inside of the ROS computer. Again, just a conceptual view of what's going on. So in that bubble there is where you put your ROS nodes. So my low-level controller connects to my vehicle interface node, and that just passes messages back and forth. And on that, I just wrote my own protocol. You can also use ROS serial, which I think both Juan and Al are using that. And there's 1 or 2 more ways to do that is officially published. And I'm just still going with the original method I started with. And then I'm just saying, okay, at the basic level, to make a physical vehicle run, and in this case, physically make it run outside, you need to have a GPS, or you could have a GPS and an associated GPS node. You may or may not want an IMU and the associated node for that. And you may or may not want a LiDAR, and here's the associated node for that. And then this, where it says navigation block, that's just a placeholder to say, you have to write some kind of ROS code to make this all work. So I just stuck it in this box called navigation block, which I'll get to in a moment. So the concept is you would write a launch file that says start up all these physical devices, and then another launch file that says start up whatever your actual code is to make your robot run. And you could then combine that into one main or master launch file. So you say go, and it would say execute the launch file to start all the physical stuff, start the launch file to start all the navigation / any other ROS things you've written, and the thing should come up and run then. So you could, at that point, you can drive your vehicle however you want to do it. And of course, one way then is fire up either on the same computer or different computer, fire up RViz and say, give it a navigation goal. And that starts the whole process off, and it should theoretically drive to that point and come to a stop. So this is a block diagram of running as a real physical vehicle. So the next one, basically, instead of starting up all the hardware devices and the hardware interface nodes, it just starts up this block that's called Gazebo block. And then I would put anything in there that it takes to make my vehicle run in a Gazebo simulator. And we'll look at that in a second. But basically, in this case, you'd have one launch file that says start up the Gazebo block, one launch file says start up the navigation block, and then a master one that says start up the Gazebo block and the navigation block. And again, a single key click will bring up your simulated vehicle. So in that case, it'll bring up a window. It brings up a Gazebo window. You can see your simulated vehicle. You can also start up RViz and then see the vehicle in RViz. And then anything else you want to run, it should be running. The goal is to get the Gazebo simulation to work interchangeably with the back to this one, which is the hardware version. And the trick is if whatever topics these are subscribing to and publishing to, as long as those match on the Gazebo block, then it should relatively transparently be able to switch back and forth. So here's what's inside of the Gazebo block. Again, this is just a conceptually, and I'm not sure this is exactly what I need, or if I need more or less of this stuff. But this is showing that in the middle you have the Gazebo node. It turns out Gazebo is actually a standalone program. So you just go to the command line and type in Gazebo, and it'll bring up your Gazebo simulator. And then ROS has, I think they call them Gazebo plugins. So basically, when you start this thing, you in your launch file, you say, run this to start Gazebo, and it starts up this Gazebo node here. And technically, Gazebo is a program out here that's running in the background and has its own display screen if you want a display screen. So it essentially, it has to have this to do the actual simulation. In order to simulate something, you have to have a URDF file that defines the model of your vehicle. So that defines all your wheels and your joints and your positions. And if you got sensors on it, it tells what the sensors are and where they're located on the vehicle. So when Gazebo starts up, you load in that URDF file, and then magically your vehicle shows up on the screen if you did everything right. Now, the other thing the URDF file is used for, like when you run a physical vehicle, and like Al is doing, he just specifies his GPS and his IMU and a couple of other sensors that are on there. And then he tells it where those are located on the vehicle in relationship to BaseLink. So when you do that, you run the robot state publisher program. It reads out the values from the URDF file and then publishes your transforms. So instead of going into a launch file saying create a static transform broadcaster, and I want to publish the difference between, say, GPS and BaseLink, and then give it all the numbers of what that is. Instead, you can put that stuff in the URDF file, again, like Al is doing, and then start up robot state publisher, and it generates that stuff just out of that file. So that's two different ways to do that. Just as a side note, I was just going to point that out. So in this case, that URDF can be used for two different things. And there's probably more things you can do with it. That's off the top of my head. That's what I can think of. So the URDF defines the model. The model gets loaded into Gazebo, and then they've got another program they supplied with this thing that I started with. It's a big Python script called Ackerman controller, and it subscribes to Ackerman message from ROS. And if you wanted to, you could hack on it and make it work with command velocity instead, but they wrote it for Ackerman message. So what I could do is I could take the translator node out of Teb Planner, and that will convert command velocity into Ackerman message. So out in my world here, I could start up a node that says convert command velocity to Ackerman message. So then Ackerman message goes into the Gazebo block, and the command velocity comes from the navigation block. So I could use that translator and not have to change the code. So anyway, if you send an Ackerman message in that says, here's your forward velocity and here's your steering angle, it tells this thing what to do. And this has lots of code in there that takes that and defines that these joint commands. It calculates the speed of all four wheels. It calculates the steering angle of the two front wheels and sends all that information into Gazebo. So the model is supplied from URDF, and the joint commands are telling it, actually manipulating the pieces of the model itself. So when you fire this thing up, you start sending it commands, and it starts moving the vehicle. So if you say move forward at 1 meter per second with a steering angle of say 0.2 radians or 0.2 radians as a steering angle, then the vehicle it'll turn its steering wheels that amount and start driving forward. So it starts driving in a circle. If you're watching the Gazebo window, you'll see it driving around in a circle. Now, also with this, there's a couple of configuration files that were also thrown into this package that I started with. And I think those go into the Ackerman controller software is where those go. It could be one of them actually goes into Gazebo node, but I'm not sure. That's more stuff I have to look at. But just conceptually, again, you've got some configuration that tells this thing what to do. And then I think the odometry calculations are done in this program and published from there. or it's possible that the Gazebo node, and there you tell it you want to publish odometry, and it creates an odometry controller and publishes it. So one of the two is putting out the odometry. And then if you want simulated sensors, here you can drop in a simulated GPS into the URDF file. And there you say, I want to add a GPS. It's located here on the vehicle. Here's the parameters as far as its range and the angle it can scan and various other things. So that will create GPS. And I haven't looked to see what that's putting out, if that's putting out a standard like a navsat fix, a navsat velocity, a navsat status, or if it just puts out something that's latitude and longitude. If it is just putting out the basic stuff, then I could write a node here to convert that into the standard like navsat fix type messages. And the same thing with an IMU. If you want an IMU on the vehicle, you just go into your URDF and say, give me an IMU. It's located here on the vehicle. And you say, I don't know if it makes any distinction between the brand of IMU, but it might have a list of things you can publish. So depending on the IMU, the physical IMU you're going to use, you look to see what topics it's publishing. And then you come back here and see, is this publishing what you want to see coming out of there? And if it is, if these messages match the real vehicle, then that will work transparently. And then one other thing back from my thing where I said, let me go back to that once. So back to here where I said, we got GPS, IMU, and LiDAR, and that's essentially the basic stuff for driving around outside. And you use basically outside, you use the LiDAR for just obstacle detection, so you don't run into things. If you're driving inside of a building, you would use your LiDAR along with AMCL, and it will take a laser scan and compare that to the map that you supplied. And then if they don't match, it nudges your position around a little bit to keep you lined up, so you know. I'm going to say exactly where you are. I don't think you ever know exactly where you are. You know approximately where you are based on that. So that's if you're running inside of a building, you also start up AMCL. I got a later slide, and I'll talk about that a little more. So the thing is, once you start up this node, when you start it, this brings up a Gazebo screen, and then it says it parses the URDF file, and then it says something like load the vehicle or instantiate the vehicle or something, at which point it drops it onto your flat plane in Gazebo, and you can see it on the screen then at that point. And as soon as you start it up, it starts publishing these transforms, so you know where GPS is in relation to base link, and scan is in relation to base link, and all this kind of stuff. And then once it starts, it also starts this Ackerman controller. So at that point, you can start giving it Ackerman messages, and you can go drive it around at that point. So regardless, so even if I have, see back this, even if I don't start up this navigation block, I can start up the Gazebo block, and then from the command line, I can say, publish this Ackerman message, and the vehicle will drive around. Or I could say, start up down here if I have a physical joystick or gamepad, and then I have a joystick node, and then I have the teleop joystick node running, that can generate messages and talk directly to the Gazebo block, and you can drive around with the joystick at that point. So then the reason I started this whole thing, I was trying to think, well, if I want to go to ROS 2, how am I going to make all this stuff work? And I did a bunch of digging. So basically in ROS 1, the stuff we just looked at, you either start up the physical objects, or you start up the simulation object. So right here, you start up one or the other, and here's your navigation block. And I can do all of this in ROS 1. And I guess there's no reason why I can't do it in Kinetic versus Noetic. But right now I'm running it under Noetic. And of course, the main difference is between the versions, they switch from Python 2.7 to Python 3.x. So that's somewhat of a difference, but you know, you can go through and figure those things out. If you really want to pick a version to run on, you could do that. So down here it's saying, well, we could have ROS 1 running, and again, either start up the physical things on the vehicle or start up the simulation instead of the vehicle. And then we don't have this navigation stuff running here, but I can start up ROS 2 and start up navigation 2 block over here. So I'm doing the actual, the modern, the newer navigation stuff that runs under ROS 2. And if you start up this ROS 1 bridge, which is a node, technically this node sits inside of here. So the node should be here, and then a line going between the two. Once you start that ROS 1 bridge, ROS 1 and ROS 2 just magically talk to each other. So I can put a node in ROS 1 and ROS2 can see that and do something with it, or I can start a node in ROS2 and ROS1 can see that. And that's important in the fact that, number one, apparently ROS1 directly talks to the simulator. If you want to go to ROS2, you got to get something called ignition Gazebo bridge or something. So it's a different way of doing it. So if I started off in ROS1 like this, then when I start up the ROS2 stuff, it's just extra stuff that's talking to the system, but the simulation would still run from ROS1. The other things are, see, like my laser scanner software, it's old enough. It was supported up through Indigo. And then when it got to Kinetic, they said, oh, we don't support it anymore. But people said, how do I compile it? There was instructions. I was able to compile it for Kinetic. And now when I jumped to load the stuff where I could run ROS2, I now have Ubuntu 2004, and I have ROS Noetic for ROS1, and then for ROS2, I have ROS Foxy. So when I did that, basically I jumped from Kinetic to Noetic to do that. And now the laser scanner, I was still able to compile it for ROS1, but I don't think I don't think I'd have any chance to get as a program to compile for ROS2. Now, if I really wanted to, I could probably go down the line and try to figure out how to translate it or try to write it from scratch. But it's just easier to leave it over here in ROS1 because it runs there and that will work. Other things I know that directly, if I want to run the CAN interface, I can directly run CAN and all the pieces on ROS1. And again, then I just have any additional stuff I can put on ROS2. So at this point, you can get just a simple thing. I guess one of the simplest things is go to ROS2 and from a command line say, create an Ackermann message, which should come all the way back through and go to the simulation with the ROS block and make my vehicle move, and then just work up from there. Then you can say, can I get the joystick to run in ROS2 and do whatever it takes to get that to run? And that should pass all the way through to the simulator. And then, so you can just, pick basic things and start adding on, just adding more and more and more until you get more stuff moved over into ROS2, if your goal is to run ROS2. And I know people are converting nodes, so I think there's more and more every day. And probably if you wanted to run ROS2, probably running on a laptop, you'd have a better chance getting that to run than running on any of the ARM boards, like say a Raspberry Pi or the NVIDIA Jetson Nano, just simply because you get support sooner on a laptop to do that. Whereas this old stuff, if you're running Kinetic on ROS1, that stuff doesn't change. You don't necessarily get the new stuff they put in, which I'm not sure how much that really hampers you on that. But anyway, this is the whole point I started on this. I want to say, well, I want to run ROS2 and I want to run ROS1 and the simulation. So that I drew this out, and that's basically how I would do that. And I haven't actually done that, but if you load up ROS1 and ROS2 on the new stuff, they tell you here's a sample. They say start up ROS1 bridge, and you run the talker and the listener program. So if you run the talker over here and the listener here, then magically, yes, the messages show up on the screen. Or you can do it the other way around. You can start the talker on this side and the listener on this side, and you start them both up. And again, magically, the messages pass back and forth. That's really all I've done with ROS2 is just to prove that it works. So this is the traditional. If you go dig through the ROS wiki or you watch everybody's presentations, they just copy this and paste it to no end. And this is just saying, if you're running navigation, these are all the pieces inside of the block. And it says move base, so I think technically it's the move base node. And then each one of these little round things is a plugin. So when you run move base, it loads all these plugins for you, and everybody's happy. And then over here on the side, if you're going to run a map, it could be always have to run a map, but it can be a blank map if you want. So this simply goes to the hard drive, loads the map into your navigation, into move base. And then down here says sensor sources. They say, well, for instance, laser scanners or point clouds. And because this was all done 10 years ago or whatever. And that's at the time, that's what they had. And then I always complained about it because over here, this stuff made no sense to me on the left here. They just drew these blocks and connected them together and say, oh, isn't that great? And then the other thing to note here is so you're putting this stuff into navigation. So you're getting odometry. If you generate odometry from your wheels, or you have a camera that generates odometry, or going through the whole process of converting GPS into something usable, that can generate an odometry message. So somewhere you put odometry into your move base node over here. And then the AMCL is if you're running indoors. If you have a laser scanner and a map, it can combine those together and then give you updates so you know where you are while you're driving around. So the other point is, the whole point of move base is you look at the map, you look at your sensors, you figure out where you are, and as you drive around, it corrects for it. And at some point you can say, click on somewhere on you go to RViz and click on a thing, say drive to this point. By giving up here, it says move base simple goal. So if you click in RViz and say go to this point, it generates that topic, sends it in here, and that kicks off the whole sequencer. It does a global plan. Once it finds that, it starts up the local planner. And well, technically the global planner uses the map that you supplied, so it knows how to get through doorways and through multiple rooms. And once it comes up with a path, it passes that local planner. And now the local planner works along with the local cost map, because the local cost map is getting laser scan or point cloud in. So it sees what objects are around you. So the local planner tries to drive through whatever obstacles are in the room. And the final outcome of this whole thing is it generates this command velocity message. And that's what actually goes out to your vehicle and says, drive forward this fast and control the steering like this. And again, as we've mentioned multiple times, the standard command velocity uses rotational velocity to define your steering. The modified command velocity in TEB Planner uses a steering angle that they wedged into this, so it becomes a modified command velocity. Or you can run an Ackermann message. Now, the point is, since that stuff I'm running wants Ackermann message, and since the TEB Planner supplies a node to convert a standard command velocity into Ackermann message, again, I could run that. So any of these standard planners, any of this standard, because there's move base and there's move base flex, but then the planners themselves, you come down to the local planner, that's actually deciding how are you going to get through the room, what's in your immediate area, how's it going to get there. And it determines that by saying, I want you to drive forward at this speed and then control the steering. So all the standard ones put out a standard command velocity. So if I just put that converter in, then I could run any of the, drop in any of the move base, either move base or move base flex. And then somebody's going to say, well, what about TEB Planner? Well, it turns out TEB Planner loads a different local planner. TEB Planner gets loaded in here as your local planner. It replaces the local planner that's there. And then you have the option, if you don't make any changes to it, it puts out a standard command velocity message, which could go through the translator and run my Ackermann stuff directly. Or in the TEB Planner, you can set a checkbox, say, no, we want to use the modified version that puts out a steering angle into the modified command velocity. So that's just a couple of notes there on, what's inside of what I'm calling the navigation block. So all this crap goes in there, and you have to start up all these. You have to start up a map server. You have to start up all the things for your sensors. You have to start up AMCL if you want to use it, and the odometry source comes in from your vehicle. So this is some of the stuff that goes in there. And once you get this set up, then you can go to RViz and just say, if you're running AMCL, you have to set your initial position. If you're running GPS here instead, so it gives you an absolute position, then you don't have to do that. But either way, then you click on the screen and say, generate this goal. And once you do, it kicks this whole thing off. It starts sending out commands. It drives until it gets there and says, okay, I'm at that point. And then the whole thing shuts down and waits for the next thing to happen. So I think and then somebody made a modern version of that. And they basically fixed the stuff on the left that I was complaining about. And so AMCL, it looks like, is actually just updating the transform to tell you where you are. And this transform source, I think, is if you have, you've defined static transforms between, say, one between base link and base footprint, and one between base link and GPS and base link and IMU and so forth. I think that's what that's telling you here. And again, you can either create that by putting command line static transform publishers into your launch file. So you can say, here's my base link, here's my base footprint, here's the difference between those two. and that generates that for you. And then you can create another one that says, this is the difference. This is the transform between baselink and GPS. And then you put all the numbers in there, and that creates your next one. So you can put all those into a launch file if you want to, or back to, let's go back to this one, or you can do it this way, which is you just inside a URDF file, you define those same things we were just talking about, and then robot state publisher reads those off and puts out the state transforms. So that's the alternate way of doing that. So that's what the transform source. I think it's taking one or the other. It's taking whatever you've defined there and update your transforms. AMCL is constantly updating transforms by looking at comparing your laser scan to your map that you supplied, and the map comes from over here. That's a predefined map from your hard drive. So that's what that's doing. And then the odometry source, say on my vehicle, I generate odometry on that and send that back up, and that gets published. And one of the things, it publishes the ODOM topic, the ODOM message, which comes right into the move base over here. And if you want, it can also generate a transform. So they're showing there's 3 different things that are updating the transforms here for you. And one other thing that needs to be fixed on this, they say, here's the base controller, which I was calling my vehicle interface node is what I was calling it. And basically this arrow is in the wrong direction. So you need to erase this thing here and put an arrow on here saying, this is the output of the local planner. It goes out to your vehicle. So this goes to a node that then communicates with a vehicle. So this shows you this is a complete low-level description of what the navigation stuff's doing. You notice on here, he also left out the recovery behaviors. And I think from my point of view, if I'm going to do an Ackerman vehicle outside of my front yard, I would probably turn the recovery behaviors off, because they work best with a differential drive, and I don't want it doing stupid things to me. And the other problem is, say it's driving around and you're going to use your joystick as a pause button. So you press your joystick, and that simply says stop listening to these command velocity messages coming out of here, and the thing will just sit there ignoring that. But if you have the recovery behaviors turned on, it says, oh, I haven't been able to move for 2 seconds. Here, let me back up, or let me start rotating in circles. Let me do all this other stupid things. But if you turn the recovery behaviors off, then as soon as you release the pause, it should say, oh, well, it's still asking me to drive around, so it should continue on. So that's just more little details that you could do to improve this, or possibly for debug, or just based on your application, you can decide if you want to have the recovery behaviors turned on or not. And other things on this, again, the map server, typically you'll, if you're driving inside of a building, you will start up, instead of starting up AMCL, you start up SLAM, one of the SLAM programs, which is simultaneous localization and mapping. So what that does, you start it up with a blank map, and then it says take your observation sources, and mine say has a laser scan on. So you start off with a blank world, and the first scan, it says, oh, I can see some walls out in front of me. So it puts those into your map, into your global cost map. As you start driving around, it starts creating a map as you go. So if you had it in your house, you drive all around the house, and then you click on a command that says save the map to the hard drive. So now you've got a permanent map out here stored. So the next time you come in, instead of starting up SLAM, you start up AMCL, and you tell it the map that you just created, and then it takes the laser scans and the map that you created, and then AMCL sets your localization and keeps you lined up with the world. That's what the map server does. So there's various things you can do with the map server. You know, if you wanted to, you could also say, in my case, if I'm going to drive around outside, I might pull up a Google map of my property, and then everywhere there's a tree, I could put like a round object there saying there's a tree there. And if there's houses, I can put rectangles for those. So I could add things into that. So I bring up the map server, and whether I'm using it to localize on or not, when I run the simulator, I want those to be obstacles so I don't run into them. So again, there's various games you can play with your map, either how you create it. You can't even create a map with pull up a graphics program, because basically the map file itself is just a pixel-based image file. So you can just go in and just draw lines and circles in a CAD program, as long as you get the proportions set up correctly. You got to know there's X number of pixels across, and each pixel is, say, a 2-inch square. So you just have to get the scaling correct to make those line up. So there is a way to do it, and I haven't got up the ambition to actually try to do that yet. And then down here, they're just saying sensor sources, and they say, for instance, a laser scanner or point clouds. And you could, with the modern stuff, they've now got 3D cameras, 3D laser scanners. They've got stereo cameras. There's all kinds of things you can put on there, or you can put sonars on the front. So that's another option to keep from running into things. If the sonar returns something, it returns it and puts it into the cost map, and then it tells the global planner it has to drive around those things. So again, this is just a, I think the rest of the stuff is just smaller. Yeah, they got smaller versions of those two files there. So that's a quick walkthrough of what, based on what my vehicle could be. That's technically not the way my vehicle is laid out, but that's the fundamental things. And the same basic thing I drew out is if I were to use this little robot that's got the two gear motors on the bottom that have optical encoders on, and then it's got a little TI eval board here that reads the encoders and talks to the power drive. There's a motor power driver here and a motor power driver over here on the vehicle. And then on the top level, it's got a Raspberry Pi 2 that's my ROS computer, and it's got this LiDAR it's one of the little LiDARs off a vacuum cleaner. So it's like, I think this was off the iRobot vacuum cleaners, or Roombas. They call them Roombas. And people will sell these on eBay anywhere from, at the time I was buying them, they're around $80 a piece for those things. And then a guy on the Dallas robotics group built this little translator board that's got a Teensy 2.0 that connects to the laser scanner to control the motor speed. It reads the laser scans, converts it to USB, and then the USB goes into the ROS computer here, into the Raspberry Pi. So essentially, that's that model I showed with the what I called my physical model. That's basically the same thing for this little robot as it is for my medium size. But for my vehicle, that's half the size of a lawn tractor, and then basically it's the same thing you would have for a lawn tractor or a full size tractor. So it's just kind of a generic. You know, that's in my opinion, that's the basic thing you want to run if you're running an outdoor vehicle. So I got far enough to think these things up, and then last night I sat down with a pen and drew these out, took my camera, and took pictures, and that's where those images came up with. So I didn't have to sit here, hold a camera over my paper on the desk. So that I got enough ambition last night to put that presentation together. I did right there. So.
How long have you had the LiDAR two-wheel deal?
About the time that the Raspberry Pi 2 came out. The Raspberry Pi 2 was the first one that would run Ubuntu on a Raspberry Pi. And I thought, okay, I'll take the plunge now. So I went through and loaded that up. And then I think I built the robot at that point. So that's a long time ago that I put that together. I got some videos on my YouTube channel that drive around. Let's see, can I find out without wasting too much time here? Well, I'm probably gonna waste a lot of time, but if I say, here's YouTube, and I say 8675-309, and here's my YouTube channel. And no, this should be the right one. Let's see, videos. Yeah, so I'll post this. And how do I get to chat? I do this. I do this. And now if I find one here. I think it's this one. So let me pull this up. Stop that, make it big enough to read. And yes, I know I'm not sharing yet. Okay, so come over here and say, share screen, this one. So this one, and I'll have to go look at the date here in a moment, but this one I think is that robot either driving in my house or driving in someone's basement at this point. I'm back here, you can briefly see it's got a laser, there's the laser scan image that's not working, and it's got a map that it loaded. It's right there. See on the right on RViz, it fired up, and that the first scan is displaying this is displaying what it sees. Now, as it drives around, it'll start filling that map in. Yep, you can see that image, can't you?
Yeah, but the different colors, is that in the intensity or something about how?
I think it is. Yeah, I think it's the intensity. When you come over here and under the display, it'll say, what do you want for color? And you can do a solid color, or you can do it based on distance or based on intensity. So that's what that's doing. So see, as the thing starts to drive around here, it's got a map. I must have already driven it around somewhat to get that, because you have to physically drive around as you do it. It builds up this map and makes it better. So anyway, let me so that's the thing. Let's go check and find out what date that was. It says 2016, April 1st of 2016. Wow. So let me.
How would that LiDAR do outside?
Not very well, because I think it's LED based, and maybe it's no, it might be a laser. It might be a laser diode, but I don't think they work very well outside. Now, if you're close distance, here, let me post this. So that's the actual video I just showed. If you go back to the main channel there's 2 or 3 more that was that driving around. But if you have a short distance, possibly outside, if I was going to mount it, say on the front to look down at the ground, it could take like a 45-degree angle looking down. So as you drive forward, you build up those scans, so you could actually create a plot of the surface of the ground, or possibly mount it on the back just to make sure. On the back, I could use it to make sure I don't back into something. And right. I'd have to experiment to see how much light it can put up with. It could be for not in direct sunlight that it'll work. And
or only drive at night.
That's the other thing. A lot of these sensors work better in total darkness. So, anything that's an infrared optical thing likes to work better in the dark anyway. So you can have this thing driving around in total darkness and still have it work.
Your neighbors wouldn't see.
Yeah, I haven't had the cops I had the neighbors call the cops on me yet, but I'm sure that's going to happen one of these days. Where I think if I start driving at night, they probably will. It's, there's somebody suspicious outside doing something that we don't understand. So, what else was I going to say there? Blah 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 blah. So you could put it on the back of the vehicle. So if it works at short range, then if you start backing up, just keep track of, so you don't back over anything. Because that one on the front, that big blue SICK LMS 200 LiDAR, you can set that to either an 8-meter range or an 80-meter range. And I haven't experimented outside in bright sunlight to see what it does. I think I asked Matt, because he's got the white version of that has some kind of industrial rating or something. I don't know if it's waterproof or whatever. But he said basically he thinks that one works, full range outdoors, that it's really not affected by the sun. So possibly I could, if I just set it to an 8-meter distance, 24 feet, that's probably good enough for, for obstacle detection. That's good enough. And possibly it's got enough power to work in that range.
Yeah, but if you went to, you have that, which is cool. But if you went to buy that today, what's the going rate for something with that sort of range?
If you want to get new ones, you can get ones for around $1,000, I think. SICK still wants like $3,000, but then the competitors will charge you like $1,000 to get something that will work. Has like 270 degrees of scan, and it goes out to some long enough distance that's usable, and they probably work outside. I hate to buy one and find out that it doesn't work. That would be a real problem. And possibly if you look on eBay, randomly you can buy someone that, somebody's trying to get rid of one that they've used and upgrade it to something modern. The ones I have, I think they were tearing down factories or something. At one point, they put a whole bunch of those out at the same time on eBay, and I ended up with 3 of them. and two of them came. The error light turns on when they power up, and one of them I went ahead and used it for a while, and after about 6 months or so, it quit working and wouldn't talk to me anymore. So I put on the other one that gets errors, and they just started randomly coming up and say, "No, I'm not going to talk anymore." And the third one, I think, was a brand new replacement unit. Came in a nice like a steel case box, whatever you call, whatever the musicians put their instruments in. They had a custom box made for that sensor, and it came in that, and it looked like it was brand new. And so far, it seems to be working just fine. But yeah, you can get the smaller ones that, you get ones that are about the size of a coffee cup that will have, the same kind of range and possibly a faster scan rate, and maybe talk over Ethernet, all kinds of fancy stuff. If you want to put out the money to buy something like that.
Well, my activity has centered on playing with this board with the notion of rejiggering. Let's see, how do I hide that? How do I hide that? Do you see that?
Yes, I do.
I don't know how to get rid of that.
Get rid of what?
It says talking Jeff, talking Al. Do you see that?
No, so it's not going through. But it does say optimize microphone pickup, but just ignore it. It's not a problem.
So this is a LORA deal with a ESP on it. I don't know if it would have enough chips or not. I just sort of randomly ordered it. There's a pinout down here. It seems to have plenty of IO pins, and it's got a little display board, and it's got LORA and an ESP32. So I bought two of them, one with the expectation one would be in the remote control and one would be on the robot, and it would be as you described in a previous discussion, you have to have a heartbeat in order to not trigger your shutdown. I mean, you use it for multiple things, but anyway, so you have manual control, and then you can switch to ROS control. But anyway, so that's what I got, that and loaded up the.
That probably also has Wi-Fi and Bluetooth on it.
Yeah.
It's not guaranteed, but it might have. Yeah, right there.
It says it does. I didn't try it. I was just focused on LORA, just to make sure that was working, but it was less expensive, and so that was what I did. Is got that and messed around with that. Not much, but a little.
Have you got it to do anything?
Yeah, I loaded the Arduino sample code from, let's see, I can find, bear with me a second. Still looking. LORA.
I was curious how well your display works on that thing. And then I'd be more curious to find out if you take it out in the sunlight, can you still read it? Being the OLED, possibly you can. I don't know.
Certainly downstairs in my basement, I was able to get it to work, and it, it was certainly readable, but I'll post this tutorial that I went through, I mean, this was a nicely laid out tutorial that basically, it's like the hello world for LORA, where you just do a blank send, and you do a listen, receive, just to make sure that it's functioning, and that all worked fine. You go through all of the installation of the libraries and whatnot, so they did a nice job of explaining all of that and give you the sketch, and they give you these Adafruit libraries and this LORA library, and that all worked without any drama for the particular board that I got.
Do you know offhand which frequency that was?
I had the 915.
Okay.
Trying to stay out of jail.
And I think the 900 megahertz one will either run at that 896 or 915. I think you can switch that in software. So if for some reason you would have interference, it's a neighbor or something is putting out stuff, you can just go and flip that in the configuration somewhere in the thing. It'll say, I'm just noticing on the as you're scrolling through the code, it said I saw Asia pop up, so I'm guessing that's what that was right there. They're telling you how to set the frequency. But the 433 megahertz is actually, that's a physically different part. So, but you've got the option of two different frequencies. So above there, they're trying to tell you can do 915. The E6, they're just doing scientific notation. So you can either run 866 megahertz or 915 megahertz. You can run those two, but the one that says 433 for Asia, you can't run that because your board physically won't do that. So just keep that in mind.
Yeah, that's interesting, because I don't think I changed this code.
Well, that's okay. It'll work just fine as long as both ends are set at the same band. Then they'll talk to each other.
And the guys in the black helicopter didn't show up at my door.
Well, that's also a legal band. Both 915 and 866 are legal bands to run these things on.
Oh yeah, wow.
But technically, 433 is not legal in the United States. But I don't think, unless somebody complains, I don't think they're going to come after anybody. Famous last words.
I just didn't realize the board physically would run at different speeds. I guess
I'm pretty sure it will.
Yeah, I'll be darned.
There they say 868, it's an 866, but I think it's 868 is what I normally see. So that's probably just a typo in there in the actual code. But if that's what they specify, go ahead and use that, because they're going to have an equate that says, set these registers to make it run at the 868 or 866, whichever is correct.
Huh.
So that's just something to keep in mind. One more thing, I'm not sure how LORA works because they don't have channels, but if you go back to your code, it'll say somewhere, it says this is either a random seed number or something. I think that's the equivalent of channels. So when it comes by default, it might say number, they put a 1 in there. I think you can pick a number like 1 to 33. I think that's just a seed number, so as it randomly switches, because these are what they call spread spectrum, and the thing is constantly jumping through like a bunch of different channels. And that's one thing that makes it, and I don't know what they're going to call it, but I know in the other code that I was running, it said something about, they just put a number in there for that. I haven't seen it yet there, but so that's something else to keep in mind, that eventually, and even if your own stuff, you say you're going to make 2 remote controls and you have 2 lawn tractors, you want to set one to the equivalent of, say, channel 1, and the other one to equivalent, say, channel 5 or something. And that way they should both work at the same time, I think. But so again, since begin band, band was just the frequency. And I don't see that right offhand. In some of the Adafruit stuff, is either Adafruit or the Teensy one. They were talking about that. So again, it's by default, it's going to work as long as the 2 are talking to each other. You know, that should work just fine. Have you had the 2 talking to each other, or you just got the displays working?
No, it's working.
Okay.
I mean, this send and receive works.
Okay.
I wonder what that 3C is all about. See if they explain it in how.
That said something about your display, so it has something to do with your display code.
Oh.
See, the function says display.begin, so it's something to do with that display they gave you. So again, that's apparently you need that to make your particular display work. You can track it down, but again, if it's working, I would probably not immediately look into that.
So that channel, maybe that's inside the.
It might be in that header. Well, that again, that's your display right there, that 1306. And then the GFX, I don't know what that is, but the one that says, I think there was the LORA header. So they might have something in there that would tell you that. And if you go back through the Adafruit tutorials as a second thing, read through this and then go back and read through the Adafruit one, and they'll give you different pieces of information here and there. But at the moment, if it's working, I would say continue on.
Yeah. So it's supposed to be a little bit warmer this weekend, so hopefully I'll crack open my electronics box and just reprogram my steering controller and reprogram my low-level steering controller with my left and right range and get back to that instead of rejiggering my.
Well, two or three meetings ago, you were complaining about your PlatformIO not working, and I did yet another search, and something popped up and says, "Oh, this is what you do to fix it. You just got to run this other piece of code." And I posted that somewhere. I don't know if I sent that to you directly or that was on one of the meetings, but somebody seemed to think that, oh, that's all you got to do to fix it. You run this extra thing that basically translates your Python version or something, and that way you wouldn't have to tear everything apart. I think you could get your PlatformIO working again if you can get that to work. There's several different ways to do that, to get the Python 3 to work in Kinetic. And that guy was he was talking about PlatformIO at the time, so I assumed, there's a good chance that if you do what he says, that should indeed work. That might even been PlatformIO on a Raspberry Pi that he was talking about.
Just to confirm, this you had in one of your posts you had asked about, was I aware of that, right? No, that's a long time ago.
Oh, it's probably after that. Yeah, that was simply defining and say, yes, it will work with Teensys. And so it could be, I posted it on one of the meetings. I don't know. I could do some digging for it later and come up with that. If not, I probably have bookmarked somewhere. But that would solve a lot of your problems, I think, if you just put in the thing that says make the modern Python work with Kinetic, and that should, according to this guy, that will solve all your PlatformIO problems. You can go back to using that again, so then you won't have to rip your box open to program it. You won't have to change from Teensies to Arduinos. It should go back to working the way it's
That
supposed
would be
to.
wonderful.
So I'll look for that later.
Because I'm like, it's sort of like, I don't have a good analog to share, but it's like having an old tractor and having to rebuild the tractor from scratch to change the tire. Anyway, how much snow's on the ground in Minneapolis?
Enough. I think they said it was like 5 or 6 inches we got a couple nights ago, and it's going to snow again today. They said it's going to be like 2 inches, and it's like 13 degrees. So he said it's going to be real light, fluffy snow and easy to shovel. So later on this afternoon, I'll go out and get rid of that.
Well, it is still February, I guess. It's 33 in Pittsburgh at the moment, so I guess, but we don't have any snow on the ground. Well, I'm going to scoot.
Well, I was looking at my here. Let me display this so I can complain. So this is it's telling me this is what my weather's doing, and it always looks really good out. You know, like at least a full week, almost 2 weeks away. It's going to be above freezing every day. But then you check it tomorrow, as you get closer, then they start dropping way down here again. So it's this is only good to like 2 or 3 days out, but that's kind of what my life looks like right now. It's still cold. Tomorrow it's not as cold. It's supposed to be above freezing on Saturday, and then it's going to be kind of around freezing for it looks like a week and a half. But every time I look at it, that changes.
I'm looking at those lows. Those lows are low.
Yeah, it's not going to get really cold here. So, but you know, a few weeks ago, it did get cold. If I say last 2 weeks. Low 0, low -2. And there's times when it does get cold. You know, it gets down to -12. But fortunately, it hasn't lasted very long. You know, we haven't had several weeks of, you know, super bitter cold weather, but just occasionally it's nasty enough that you want to make sure you go out and start your car first. You know, start your car and let it warm up to make sure it's going to get where you're going.
Sure.
So anyway, I just wanted to complain about my weather, and I should have taken a picture of my snow out front. You know, I've got the one picture that I took last year of snow and snow on my car. Well, now I've got big drifts out there where I piled the snow up. So I should have taken a new picture of that, but I decided it wasn't going to show up well enough anyway. So it doesn't matter.
I empathize with you greatly. March starts to change here, so I'm almost to a point where being able to tolerate it. So I don't think I could handle Minneapolis.
I can't either, but I'm too lazy to move. So that's the way it goes.
Okay.
I'll stop the recording.